Okay. So, my talk this morning is on cloud computing and its free potential. Can everyone hear me okay? Yep. Okay, so a quick couple of words about myself. My name is Tom Raftery, as you've heard. Just need to turn this on. Okay. Hopefully that's better. So, my name is Tom Raftery. I work for an industry analyst firm called RedMonk. My area of interest within RedMonk, or the area I specialize in, is energy and sustainability. We've termed the practice within RedMonk that concentrates on energy and sustainability GreenMonk. So the place that I blog at is at greenmonk.net. A little bit about my past. I worked in an organization called Zenith Solution back in the 90s and early 2000s, and Zenith Solutions was a software company creating what has now become termed cloud applications. At the time we called them web applications. They were web-based software with a database backend online. Then I worked for a company called Chip Electronics in the early 2000s, and Chip Electronics was again a company which created enterprise resource planning ERP applications which were cloud delivered. At the time we called it software as a service. No, at the time we called it active service provision. It's since become software as a service. And I've also a co-founder and director of CIX, which is a hyper-energy efficient data center based in Cork in Ireland. So I know it both from the hardware side and the software side. I mentioned I blog on greenmonk.net. I'm on Twitter at twitter.com/TomRaftery. My email address is there. My mobile phone number is there. Please don't ring it now. And this site here, slideshare.net, the last line there, and I'm sorry for the bullet points. I don't normally use them, but I did just here, and in one other slide. Slideshare.net is a site where you can upload presentations. So this presentation I'm giving this morning, I uploaded it to SlideShare earlier this morning, so it's already online there at that site. And if you go there now, you'll see it has already been viewed over 277 times so far. So it's a great site for getting your talks out and available. It's also downloadable there. One thing you'll notice as well about the structure of my talks is a lot of them have images like this, but they also have this bit of text at the bottom, which you can't read. Don't try right now. But what they are is those are links to the source material. So if at any point you do download the presentation, you can go and click on the links. They're clickable links. You can click on them and see where I've got the information from. So that's me. Who are you guys? A couple of questions. So how many people here have deployed applications to the cloud? Not very many. How many plan to? A few more. Okay. How many people here think that cloud computing is green? Okay, good few people. Right. I hope to burst that bubble. Unlike Nancy, who spoke just a minute ago, I'm not a believer that cloud computing is green, and I hope to explain why. I am a huge fan of cloud computing, I have to say. I use it extensively. Going back to this slide for a second, the Chip application, the Zenith stuff, the GreenMonk, Twitter, SlideShare, even my email are all cloud delivered. Our organization, RedMonk, we use Google applications for domains for our email, so my email is cloud delivered as well. So I am a big user of and believer in cloud for lots of things, but I just don't happen to believe it's green. So, what is cloud computing? Well, at kind of first blush, it's software that's delivered in a browser. So that's a very easy definition of it. Something we can all kind of sign up to. It's a lot more complex than that at various other levels, and I'll go through a couple of those other levels as well, just very briefly to kind of give you the kind of complexity that's involved in it, but I'm not going to go into any great depth. So it's also nothing that's very new. This is the original sign-up screen for Hotmail. Hotmail was an email application developed and sold to Microsoft back in '97 for $450 million, if memory serves. But this was before it was sold to Microsoft. This was the original sign-up screen when they launched in July '96. and it was one of the first widely used software as a service or cloud applications. So cloud is nothing new. It keeps getting rebranded. So the cloud name is newish, all right, but the delivery mechanism is not that new. It actually harps back to mainframe computing back in the 60s even. So there are several types of cloud computing. And the first type, the first level of cloud computing is kind of software as a service. That's where you kind of take your packaged software and convert it into something, as I mentioned already, delivered in a browser. And I mean, you've probably all aware of these. I mentioned Hotmail and its analogs, the Google applications. There's also Zoho. There's social networking, the Twitter that I mentioned, SlideShare, all these kind of things. They're all software as a service. So they're just basic applications that you access through a browser. But you can go back one level of abstraction from that to where you get to what's called platform as a service. And don't worry about these acronyms. Basically, a lot of the times you don't need to know this stuff. The platform as a service stuff is where you, as I say, you go back one level of abstraction and you give people a platform on which to deploy cloud applications. And kind of the kind of platforms that you can get are ones like the Google App Engine and Amazon and Microsoft's Azure. These are the kind of platforms that are available if you want to go down that route. Most people don't need to go there, but if you do, that kind of stuff is available as well. And then you can go back one further level of abstraction where you're actually delivering hardware as a service. And this is called hardware as a service or infrastructure as a service. And both names are valid, HAAS for hardware or IaaS for infrastructure as a service. And that's where you're delivering stuff like networking, storage, compute, CPU cycles, that kind of thing as a service. And VMware, Rackspace, OpenStack, again, Amazon with their EC2 and their S3 services are those kinds of types of cloud computing. If that's a little confusing, and I know it can be, this is a slide which is also confusing, but if you actually stop and study it in your own time, if you download this application and you're interested in finding out about it, this is a good way of seeing how the different types of cloud computing stack up, as it were. So over here on the very left, you have your traditional packaged software with the entire stack from networking up through applications where you manage the entire stack on your own machine. So that's the traditional Microsoft Office, whatever, applications. You do the whole thing. Over on the other side, you've got your software as a service. Something like Google Apps for Domains or one of these things where the provider, the Google or whoever, are responsible for the entire stack. All you have is a browser. And then in the middle, you have the two other ones, a platform as a service where the vendor manages up to here and you manage the applications and data, or infrastructure where the vendor manages just this part and you manage the rest. So that's the kind of way it stacks up. As I say, on the deck itself, there's a link down there to where you can find that image if you're interested in checking into it. It's quite a nice way of seeing the differences between the different types of cloud computing. And then just to complicate things a little further, there are different deployment mechanisms. You can have private cloud, where private cloud is hosted by yourself on your own infrastructure behind your own firewall. You can have public cloud, which is what most people are familiar with. Or you can have a hybrid, where you have some stuff private, some stuff public. And that's one that a lot of people are looking at because it means you can have your data behind your firewall, but the functionality, you're accessing it from public. So your stuff remains on-premise. And that's quite important because, as Nancy alluded to, there can be a lot of issues with the data in cloud computing because, for example, if you're a European company, do you really want your data hosted on servers in US territories where, for example, the data privacy laws are a lot more lax? So I've spoken to several European companies who have said categorically they will not use cloud computing if their data is going to be hosted in US territories. It's only if it's in the EU and only if they know where in the EU. So you're now seeing cloud providers taking that on board and starting to become aware of those issues. And while they can't change US law, they can start providing storage mechanisms that they're guaranteed to be in region. So that's cloud computing. And the next question we get to is it really energy efficient? Because lots of people say it is, and even Nancy alluded to that report from the Carbon Disclosure Project, which I'll blow apart in a minute. They weren't the only ones. Microsoft, Accenture, and WSP Environment brought out this study in November of last year. And this is the actual title of the study, where they say it shows significant energy and carbon emissions reduction potential from cloud computing. And again, the link to the report is down there at the bottom. The difficulties I have with that are several. First is Microsoft are a cloud computing provider, so they kind of skin in the game. The second is that they don't actually use any hard data. It's all imputed. And the third is that after months and months of work from all these people, the best they could come up with is they could say it has potential. Yeah, it has potential to end world hunger and bring on world peace and fix the euro. Anything can have potential. So that's a non-report. So, cloud computing has phenomenal advantages, don't get me wrong. I'm a big fan. So if you're into traditional IT, you know well that if you're deploying a new application or a new server, it's painstaking. You have to go through an RFP process, a speccing process, a PO process. You have to go out to tender. You have to place the order. The order then can take several weeks from the supplier. When it comes in, it goes into the logistics area. You've got to get the guys in warehousing to tell you where the server is. You've got to go get the server. You've got to put the company image on the server. You've got to install the applications. You've got to do testing. You've got to patch the server. The list, it goes on and on. Basically, you want to deploy a new server. It's a process that can take weeks to months. You deploy a cloud application. There's usually no RFP and no PO process because the capital cost is minimal. So typically, the time to deploy for a cloud application shrinks from weeks to months to hours to minutes, depending on what you're deploying. So phenomenal. Cloud is fantastic for streamlining that kind of stuff. It's also great for what's called dynamic provisioning. So this is the Alexa graph, the website traffic of a website for the Australian Open. The Australian Open is a big tennis competition, happens in Australia every January. So you'll notice 11 months of the year, no traffic to the site. Come December, January, boom, spike. That's 2006, 2007, larger spike, 2008, larger spike, and the spikes keep getting bigger as you go that direction. So if you were the website owner for the AustralianOpen.com website, you would need to have, if there were no cloud computing options, you would need to have servers that could hit and deal with the traffic at this growing spike for 12 months of the year when the traffic is only there 1 month of the year. But with dynamic provisioning and cloud computing, you can use the elasticity of the cloud to turn up the resources assigned to that site as the traffic starts to build up in December and January. And then as the traffic falls off, you turn it back down again. So in that respect, cloud computing is fantastic as well. You're not using resources needlessly. We've also got the idea of multi-tenancy, and if you can't see what's in this picture, it's actually a Mini Cooper with 26 people inside in it. EMC sponsored it as the world record attempt to fit people into a Mini Cooper, and they fit 26 people into it. So they stuffed people into it. With multi-tenancy in cloud computing, it means you're sharing applications across companies. Lots of different companies, often competitors, are using the same single version of the application. And that's fantastic. That adds great value. You've only one instance of the application, which is great as well for updates. Updates of the application are instantly deployed. You don't have to download the latest update and apply it to the test server, make sure it works in the environment, the whole thing. No, it's just instantly on. There's the issue of server utilization, which again Nancy referred to. Nancy, you stole my talk. Come on. So this is a typical graph of server utilization. And you can see this is the memory part, but this is the server utilization, and it's at 0% here. And while that's a bit of an outlier, you'll often get, in normal servers, you'll often get utilizations in single digits, 7-8% server utilization for traditional servers in data center environments. But with the advent of virtualization and cloud computing, you can ramp that up significantly. So that should be quite energy efficient. Then you've got this kind of outlier thing called chasing the moon, which you may or may not have heard of. It's one I'm kind of fond of as an idea, but not many people have deployed it yet. People are kind of talking about it as out there. And what it is with cloud computing, if you've got data centers in, say, US West Coast, another in Northern Europe, or Southern Europe, but Northern Europe typically because it's cooler there. And cooler, I mean colder, not hip and cool. And you've got another data center, say, somewhere in Asia or Eastern Russia. Then you've got the time zones covered about 8 hours apart. So if you have applications in those, if you have an application in those 3 centers, you can move the compute to where energy is cheapest at any particular point in time. So if you're doing that, typically energy is cheapest when it's in highest supply. When it's in highest supply and it's cheapest, it's actually, this is on the wholesale market, it's actually greenest as well. So when electricity is at its cheapest, it's actually also at its greenest. It's kind of counterintuitive, but I can explain that to anyone who's interested later. So if you move your compute to where the energy and the compute is cheapest at any point in time, it's typically night time when the wind is blowing. And at that time, you're chasing the moon. You're putting your applications wherever the moon is out. So it's called chasing the moon. It's something you could only do, something that's only made possible by the likes of cloud computing. Your information is ubiquitous. It's wherever you have an internet connection. So your road warriors, your salespeople on the road can access the application while sitting at the beach. It also enables a lot more home working, home shoring, teleworking, whatever you want to call it. And people like AT&T, IBM, lots of big companies are huge fans of this. IBM reported a couple of years back now that 25% of their employees did teleworking, and those 25% were saving IBM $700 million a year. That's significant savings. And a lot of that savings comes from a lower real estate footprint and a lower energy footprint because of the lower real estate footprint. So is it energy efficient, or are a lot of those savings coming from less commuting or from less building stock? Or are they from offsetting your energy? So if you're working from home, you're still burning energy. It's just not in your company's building, and your company isn't accounting for it anymore. These are kind of questions we're not sure of. There hasn't been any definitive studies either way, and it's difficult anyway because it differs in every company and every geography. One huge problem I have with cloud computing, and people saying that cloud computing is energy efficient, is that none of the cloud providers are publishing data around their energy utilization. Not one of them. So I often do a kind of a hands-up exercise at this point, and I don't know if it'll work here because very few people admitted that they were going to be putting stuff in the cloud, but let's raise hands again. Hands up everyone who has or planned to deploy applications to the cloud. Okay, so keep your hands up, keep your hands up. Now, keep your hands up if you know the current energy utilization of the applications you're going to deploy to the cloud, or the energy applications you have already deployed to the cloud. If you know how much energy your applications burn, keep your hands up. Okay, we've got one. Anyone else? Just the one? Good. Okay, keep your hand up. We're not finished. Okay, keep your hand up if you know the energy utilization of that application in the cloud. You do? Is it a private cloud?
Actually, it's an SAP cloud for an SAP application.
And they're giving you the energy utilization of that?
We know that. We do know that. We know the cost of we know the cost. There's an excellent website where you can calculate your energy consumption. And you can put also the cost. We know the cost. So you can calculate the cost and make a determination of the value.
Okay. I'm interested in that because I do a lot of work for SAP, and they can never tell me the energy utilization of any of their cloud infrastructure. I think, okay, I must get back to you on that, because that if that is the case, it must be very new, because it's not something they've ever shown me before. And if they do it, it's often kind of what we call homologated. It's often they'll give you an average, but they won't tell you exactly what your application and what your users are utilizing, which is what you need to know. So, as I say, with the possible exception of SAP, most cloud providers do not provide the data. So without that data, we have no way of knowing if our applications are, in fact, energy efficient in the cloud. Even if they are, energy efficiency is not the same as being green. Just because something is energy efficient does not mean it's green. And this is a very common mistake that people make. So, what is green? Well, I'm also going to quote from the CDC report that Nancy mentioned. And this CDC report, it's called Cloud Computing, the IT Solution for the 21st Century, and again, there's a link to it there. One of the quotes that the CDC put into that was that a typical food and beverage firm transitioning its HR applications from dedicated IT to a public cloud can reduce CO2 emissions by 30,000 metric tons over 5 years. That sounds good. I'd buy that. That sounds quite green, actually. They also went on, though, in their executive summary, to say allowing companies to maximize performance, drive down costs, reduce inefficiency, and minimize energy use, and therefore carbon emissions. So they've made the classic fundamental mistake of thinking that reducing or making something energy efficient makes it green or reduces emissions. There is nothing that says that is the case. And I'll tell you why. And by the way, Nancy, this is the blog post I wrote on GreenMonk where I explain in significant detail why the CDC report is completely flawed. So there's a link there. You can go and have a look. I'll give it to you later. I'll give you the link later. So 2 reasons why that report is deeply flawed. One of them is it's based on assumptions, and they say so in their model. They say their model is based on assumptions. And the second is it's based on a metric called PUE. So I'll get to PUE in a second. PUE is power usage efficiency. Anyone here familiar with the term PUE? A couple are, okay. So I'll get to it in a second. They based their model on this PUE metric, which is a widely used metric, but they've based it on an average PUE across the entire United States, which is put out by the EPA. So that's not really very indicative, firstly. But secondly, PUE, the measurement itself, it's a ratio of the total amount of power used by a data center compared to the power delivered to the computer equipment. So the total power delivered to a data center is the power delivered literally to the door of the data center, which goes to power the lighting, it goes to power the cooling, it goes to power the UPSs, the whole thing. That's the total power. And it's a ratio of that to the amount of power which actually makes it to the IT equipment. So the closer your PUE figure is to 1.0, the better. Now, a couple of problems with PUE as a metric. The first is there hasn't traditionally been any standard about where you measure the power. It's measured at the meter, the power meter, the electricity company power meter. But in data centers, that has often been measured on the high voltage side, the medium voltage side, or the low voltage side, depending on the data center, depending on where they put the meter. And of course, if you're measuring it at these different places, one data center measured it at one place, another at another place, you can't cross-compare because you're leaving out the losses that occur in the conversion from high to medium to low voltage. So right there, the lack of standardization. That's being worked on at the moment, and it is getting better. They are starting to standardize, but traditionally it hasn't been standardized. So that's one issue straight away. But even more important is, quick look at this graph here. If I have a data center which takes in 2 megawatts of power, and of those 2 megawatts of power, 1 megawatt goes to powering the servers, then I have a PUE of 2.0. Very simple. However, if I realize that my 1 megawatt isn't being used very efficiently, and I realize that some of my servers are being underutilized, maybe I virtualize some of them and I shut some of them down, then my power draw from my IT equipment drops to 0.75 of a megawatt. My total draw drops to 1.75, and my PUE goes up to 2.33. Remember I said PUE closer to 1.0 means you're more efficient? I've actually made it more efficient, and my PUE has gone from 2 to 2.3. So that's a huge problem right there with the PUE metric. Another issue, and I'm sorry this is a little bit complex, but I'll walk you through it again. Another issue with PUE is it takes no account of carbon. So, top line is a typical data center. Typical data center in a European country where the supply of power causes of CO2 per kilowatt hour. That's not unusual. That's a pretty average figure. So if the typical data center is a PUE of 1.5, which is quite good, then we get 1.5 by 0.5, we get 0.75 kilograms CO2 per kilowatt hour is the IT carbon intensity. It's how much the IT equipment is producing in terms of CO2. So, if we have a data center with a good PUE, 1.2, and that good data center is drawing mostly from coal-fired power. So it's got a supply carbon intensity of 0.8 kilos. Then your 0.8 by 1.2 means you're producing, even though you've got a good PUE in your data center, you're producing 0.96 kilos CO2 per kilowatt hour. On the other hand, if you've got a really bad data center with a PUE of 3, very inefficient data center, PUE of 3, but it's fired mostly by renewables. So your carbon intensity on your supply is 0.2, which still, it's not 0, it's 0.2. It's significant. There's still carbon being produced per kilowatt hour. 0.2 by 3 gives you 0.6, which is significantly less. It's 60% of the carbon intensity of the data center with a PUE of 1.2. So PUE is no indicator whatsoever of how green something is. It's a very bad metric. There is another metric called the CUE, the carbon usage efficiency, but it's not widely used by the industry, unfortunately. So given that, the report that the CDC produced could just as easily have said that your typical HR firm or your typical food and beverage firm transitioning HR to dedicated public cloud could increase CO2 emissions by 30,000. It's just as valid. They picked the number out of the air, and they based it on a flawed metric. So it's just as valid to say it could increase CO2 as decrease CO2. And a good example of this, in fact, is Facebook. Facebook built this lovely new data center in Prineville, Oregon. They opened it earlier this year. Had an unbelievable PUE coming in around 1.08. Highly efficient. They've open sourced it. If you go to opencompute.org, you can get the blueprints for building the data center and the list of suppliers, so you can go and build that same data center yourself. They reduced their energy consumption per unit of computing by 38%. That's fantastic. That's really good. Unfortunately, their energy supplier is a company called PacificCore. PacificCore produces 58% of its power from coal. This is their website. They say it themselves right there. They produce 9.6 million tons of coal from their own mines every year. They also produce another 12% of their electricity from natural gas. So that's 70% they produce from fossil fuels. Plus, they also buy 22.5% of their power from other suppliers. Now, they don't say how those other suppliers generate theirs. So they get at least 70 and possibly significantly more of their energy from fossil fuels. So right there, Facebook's really impressive 1.08 PUE is blown out of the water by the fact that it's all produced using carbon, or almost all. To contrast that, this is a graph of power production on the Spanish grid. I picked Spain because I happen to live there. And you can see that this was taken last Friday, the snapshot. And again, you can get this information from the Red Eléctrica de España. The red bar here, or bar, whatever it is, area, is coal. Comes in around 20%. Green one here is wind, the other is the rest of the renewables put together, except water, which is down here. So on the Spanish grid, carbon intensity comes in around 20% at the moment based on that, plus the gas is another 15 to 20%, sorry. And that's actually bad compared to the same grid 2 years ago. The same grid 2 years ago, coal was coming in single digits, here around 9%. And the reason it's gone from the 9% of 2 years ago to 20% today is because Zapatero, the now former president of the parliament, comes from Castilla y León, which is a coal-producing part of Spain. And he went to the EU and he petitioned for years to be allowed to give subsidies to the coal miners and the coal production in that part of Spain. And last February 2010, he succeeded. And they got €4.5 billion in subsidies for producing coal in Spain, and that's a direct result. It's scandalous. Anyway, that's neither here nor there. Let's move on. Dublin. I'm originally from Cork, so I'll talk up Ireland for a little bit. Dublin has become a key European data center hub. Most of the big data center providers have significant operations in Dublin. Microsoft have their largest data center outside of the US in Dublin. It provides the Microsoft Live and Azure services for EMEA. Similarly, Amazon are there, Google are there. They all have significant centers there, and they're all expanding. Google have announced a new expansion, as have Microsoft, to their facilities. Unfortunately, Ireland produces 84% of its electricity from fossil fuels. That number is falling as it rolls out wind. It was 87% a couple of years ago, but now it's 84%. So that's not really very green. On the other hand, Apple have announced their iCloud service. And their iCloud service is currently housed in this data center in North Carolina. There's a photograph of it under construction. Unfortunately, this data center gets 78% of its energy from Duke Energy, who get it from, no, they get all of their energy from Duke Energy. Duke Energy get their energy from 78% coal and nuclear. Coal is obviously really bad. Nuclear is also really bad, not just because of the Fukushima reasons, but you got to think as well, nuclear power plants have an enormous water footprint. And that it can often be devastating to the environment around them. But Apple have said, in fairness to them, that they've got a 121-acre site behind them that they're now clearing for scrub to install a solar facility. It'll mitigate a little bit their emissions. A 121-acre solar facility is not going to completely power the plant, and it certainly won't power it at nighttime. But it will help, at least. Google are the really interesting player in this field, because Google have gone to extreme lengths to get their carbon footprint down to zero. They've signed power purchase agreements with wind farms. A power purchase agreement is where you sign on the dotted line with a wind farm or anyone, in this case it's wind farms in Google's case, you sign on the dotted line and you say, for the next X years, and in Google's case it's the next 20 years, I will take all of your power. All of it. For wind farms, that's a huge win, because it means they can go to investors and say, we've got checks rolling in from Google for the next 20 years, guaranteed, and here's a contract. Do you want to invest in us now? So obviously, it'll help them get investment, inward investment. It's a great win for Google on two fronts. One is they've got guaranteed renewable energy, and the second is they've got guaranteed pricing for their energy for the next 20 years. How many people can say they know what the price of their electricity is going to be in 20 years? So they've done it in a number of wind farms. This one is in Iowa, 114 megawatts. This one is in Oklahoma, another 100 megawatts. And they've gone to incredible lengths. And this is the slide I mentioned earlier with all the bullet points. And I'm really sorry. This slide has more bullet points than I normally have in entire talks. So there's 9 bullet points in this, but it gives you an idea of the investments that Google have made in renewable energy. The Potter drilling one is for geothermal. McCanny Power is for high altitude wind power. Solar City, the Atlantic Wind Connection. That's I can't remember how long it is. It's a massive offshore wind farm off the east coast of the US, and they've invested in the infrastructure of that. They own a percentage of the infrastructure in that. In total, Google have invested $850 million on renewables. So if anyone could be slightly green, I guess, in cloud, it would be Google. Having said that, though, there's a lot of having said that in this presentation. I'm sorry about that. It's a complex area. Jevons paradox. William Stanley Jevons was an economist in the 19th century in England. And he realized that as steam engines were being made more efficient in burning coal, as they were getting more efficient at burning coal, the amount of coal being burned was actually going up, not down. It was kind of counterintuitive. But how it worked was, as steam engines became more efficient, the price dropped, more people bought them, more coal was burnt. And it's similar with cloud computing. As cloud computing goes and starts taking off in adoption, the resources that are used actually go up, not down. So cloud computing leads to an increase in consumption. And there's also then Parkinson's law, and a corollary of Parkinson's law, which says data expands to fill the space available for storage. The more storage you have, the quicker it fills up. You all know that. And a good example of that is when Gmail started in 2004, Hotmail had a 2 meg limit on the size of your inbox. Yahoo had 4 meg. And Gmail said, nah, 1 gigabyte. Blew them out of the water, and suddenly they had to catch up and go to 1 gigabyte. Google is now at 7.5 gigabyte, and they allow you to send emails of 25 megabyte, single email, 25 megabytes. So also a nice quote I got from InfoChimp's Flip Cromer. And this really characterizes how cloud computing can promote consumption. And Chip said it very well when he said EC2, which is one of Amazon's offerings in cloud, means anyone with a $10 bill can rent a 10-machine cluster with a terabyte of distributed storage for 8 hours. And because it costs virtually nothing to do it, and because anyone can do it, it happens all the time. So that's not very green. You confused yet? So what if, ultimate irony, you had cloud-delivered green software? Hurrah, neutral, SAP's carbon impact on demand. These are all carbon management applications which are cloud-delivered. Now I'm really confused. I don't know if they're green or not. Microsoft Eye on Earth, cloud-delivered using the Azure platform for managing air quality, water quality, noise pollution, that kind of thing. I think my head just exploded. So my conclusion from all this is that cloud computing has a significant number of advantages. But being green isn't one of them. One last thing. If you are deploying stuff to the cloud, this is not really how you want to do it.
What are you trying to do?
Put my data center in the cloud.
Thanks very much.